Welcome. Back in February, I did a presentation at CanBIM Vancouver about how I taught myself Dynamo for Revit. And as part of that presentation, I did a video of me scripting a geodesic dome in Dynamo. It was part of a larger portfolio piece I did back in 2016 and 2017. And part of my reason for redoing this script and doing a screen capture of it is I wanted a way to get to the more advanced and meaty topics in Dynamo without having to go through a lot of the basic stuff. So the whole script took me about an hour and a half to do, and I shrunk it down to about a 5-minute video. One of the reasons that a geodesic dome is a good project challenge is that the form itself doesn't lend itself well to being rendered by hand, nor is it easy to click in 3D space all those different points. This is a form that's best derived computationally. So you'll see with this script, I sort of start with these planes that are in the ratio of the golden ratio, and they're all kind of intersected, and then I interconnect their corners to make an isohedron, which is a 20-sided object of equilateral triangles. And then I sort of add all sorts of logic to be able to control the triangle subdivisions and also scale it up. Okay, so you can see there on the left-hand side is some of that pre-processing I did for the project there of making all the points for the isohedron. I had to sort of lace them all together manually there, didn't want to bore anybody, but now you can see I'm sort of working through getting some of the geometry from that initial one big isohedron surface. And so as I sort of manipulate some of the geometry in it, I'm finding certain parameters on those lines, so that later I can then generalize to any number of subdivisions, any orientation in space. And it starts by just sort of being able to find its sort of general parameters. The next thing is that I noticed that my dome is sort of above the ground plane there, and of course you're making a dome, so you need to move it down. So it moved it the wrong direction there, so we got to fix that in a second. There we go. And now we have something that's looking a bit more like a dome, but it's still very, very, very small. So I'm going to start building in the first parameter here, and that's something, the tessellation iterations, and that's the number of times that we're going to subdivide each triangle. So again, we're sort of finding, it comes in as a surface, and the first thing we need to do is break down some of the geometry and also build in some logic to understand its length in relation to how many subdivisions we're going to then put in it. And of course, a lot of this is getting certain parts of the geometry and find out how they're orientated in space. And of course, you do that in computer science and math with vectors. And so I sort of use vectors to find its orientation in space, and then we can sort of generalize that and move all these smaller surfaces back to the larger sphere later on. And so now this is the sort of the formal logic to actually find out how many subdivisions are when you make a iteration. And there's more and more and more pieces as you increase the number of subdivisions. We have to generalize it for any number. And now we'll finally start seeing some of the results here. This is just a bit more logic as I try to sort of list and then lace together the different points we need for every different sub-triangle there. And now here's a bit of a display function here, so we'll actually be able to see what we're doing. There we go. And so now when we actually just do the actual list manipulation, you can see that we've now managed to subdivide the triangles. But it's still not very sphere-like at all. And so the way I decided to do a sphere, or how to scale it up, was project it to a sphere. So right now it's still very, very small, but you'll see me create a sphere here, and then we're going to project all those points out onto it. So of course there's more finding the different orientations in space and the different vectors from the center of the dome to the point on the surface of the sphere. And then we just sort of do a bit more logic there to find out where they land. Here we go, and we'll actually project it onto the sphere here. There we go. And so now we need to start lacing together all those surfaces back that we have the points where they need to be in the actual second parameter of how big we want this dome. So after we lace them back together, sort of carefully manipulating the lists, we're going to put it into one... first we have to, it's still very spherical when you make it a dome. So I just built in this little tolerance toggle here that allows a function to sort of search which lines and surfaces are below the horizon, and then we sort of get a dome. And then so to make sure we don't get any duplicates, right now there's lots of different surfaces, you make it into one big surface, and then you'll see me extrapolate all the edges again. These are just single edges, but these edges now, just because it's a single edge, are now perfect to place structural members on. So then we'll run through some tests here, we'll scale it and work through a couple different iterations. Everything's looking good. And now on those individual, on that individual geometry, we will place some steel elements. And we'll open up REVIT here and we'll see that everything's sort of working. Do some more tests. Looking good, looking good. And just a couple more tests to see any more adjustments. Everything looking like it is coming together quite fine. And so that is the code for the dome. So that's how you make a geodesic dome in Dynamo. Of course, there's all sorts of refinement you can do to that script to make it more creative and playful, but really from that basic, you can go out into the world and make all the geodesic domes you want. If you enjoyed this video, I ask you to please like and share. I've put my LinkedIn and Instagram in the description to this video, and of course, please build a lot. Thank you so much.